Welcome back to All This Math. This is Professor Parker, and we're back doing some Praxis prep problems. All right, so this problem says, what is the product of the following expression? Here's our expression. The quantity, because whenever terms are written inside parentheses, we call that a quantity. So the quantity of 4x minus 8 times the quantity of 5x squared plus x plus 6. All right. So the way to do this problem is essentially this 4x right here needs to be multiplied by each of these terms in the other quantity. The 4x needs to be multiplied by each of these three terms. And then this negative 8, and it is negative because of the minus sign, this negative 8 needs to also be multiplied by each of these three terms in this parentheses. And then after you do all the multiplication, you should end up with 6 terms because you're going to have 3 from multiplying 4x by each of these three. That's going to give you 3 terms. Then you have another 3 after you multiply negative 8 by each of these 3 terms. And you just write them down. And while you're multiplying, you're going to be using the exponent rule for multiplication. So you need to know your exponent rules in order to do this effectively and correctly. You need to know the multiplication rule for exponents, or some textbooks call it the multiplication property. All right, so, and this is only one way to do this problem. There are multiple ways to do a problem like this, but that's one way. That's the most straightforward, the most commonly accepted way to do these problems, right? And then after you do the multiplication, then you look for what are called like terms. And then you want to combine your like terms. So your like terms must be combined in order to simplify the expression, all right? So let's get started. So first we're going to do 4x times 5x squared. 4x times 5x squared. So what I think I'm going to do is I like to draw lines to show what's happening. All right. So this 4x is going to be multiplied by 5x squared. All right. Now, what is 4x times 5x squared? So I'm going to multiply the 4 by the 5, which gives me 20. 4 times 5 gives me 20. And then I'm going to multiply x times x squared, which gives me x to the 3rd power. That's where I use the multiplication rule for exponents. The multiplication rule for exponents tells me that you need to add the exponents together when you multiply terms. So x times x, 1 plus 2 is 3. 20, x to the 3rd. Where's the 20 come from? 4 times 5. Where's the x to the 3rd come from? X times x squared. So you have to memorize that rule, the multiplication rule for exponents. So we got 20 x to the 3rd. All right, and now we're going to multiply 4x times x. Now you might be wondering, well, what do I multiply the 4 by? You multiply the 4 by this invisible 1 coefficient. So when no coefficient is written, see, 4 is a coefficient, right? 5 is a coefficient. But when you don't see a coefficient, just know that there's an invisible 1 there for your coefficient. So now we do 4 times 1, which is 4, and x times x, which is x to the 2nd power, or x squared, because you add the exponents. The multiplication exponent rule says you add the exponents. You don't add the terms, you don't add the x's, you add their exponents. You add their exponents. So 4 times 1 is 4, so I write plus 4, and then x times x is x squared. All right, now 4x times 6. 6 doesn't have an x term. But we have 4 and 6. So 4 times 6 is going to be 24. And then x is just going to be part of the product. So we have plus 24x. So these are our 3 products that result from us multiplying 4x by each of these 3 terms. Okay? Now we go to the negative 8. We go to the negative 8. Now we do negative 8. And you know what? I forgot to label everything. I said I was going to label because we did 4x times 5x squared. Then we do 4x times x. And then we do 4x times 6. Right? That's how we got these 3 terms. 20x to the 3rd, 4x squared, and 24x. By doing 4x times 5x squared, 4x times x gave me that. 4x times 6 gave me that. That's how I got those 3 terms. Now we're about to get another 3 terms from doing negative 8 times each of these 3. All right? So first we're going to do negative 8 times the 5x squared. Then we're going to do negative 8 times the x. Then we're going to do negative 8 times 6. All right, we're going to do each of those 3. So negative 8 times 5 is negative 40. That's negative 40. So we're going to have minus 40, but then 5 has 5x squared. This is 5x squared. So we're going to have minus 40x squared. And then we got negative 8 times x. So it's really negative 8 times the invisible 1, which is negative 8. And then x is just part of the product. All right. So I got 2 of my 3 terms that I need from the negative 8 being multiplied by each of these 3. And then I got negative 8 times 6. So just think of your multiplication facts. Negative 8 times 6 is negative 48. So I got minus 48. So now I got my 6 terms. Like I told you from the beginning, we were going to end up with 6 terms. We were going to end up with 1, 2, 3, 4, 5, 6. And terms are separated by plus or minus signs. So that's why 8x or negative 8x is different from negative 48. This is a different term. That's a different term. That's a different term. And that's a different term. Now our job is to combine like terms. Now, how do I know what like terms are? Number 1, all numbers are alike. Numbers that are just numbers. Numbers that aren't attached to variables. All numbers are alike. So negative numbers, positive numbers, big numbers, small numbers, decimals, fractions, radicals, those are all numbers, and they're all considered like terms. They all can be added or subtracted from each other. They can. They all can be added or subtracted from each other. It gets a little tricky when you get to radicals, but basically, fundamentally, those are like they're alike to other numbers. But you may need to simplify or evaluate the radical and then do the thing. You create your decimal or whatever, and then do the thing. But variables, when it comes to variables. Variables are alike if they're the same variable and they got the same exponent. They gotta have the same exponent. So dig this. X to the third is not alike. It's not the same as, or is not alike to x squared. So x to the third and x squared are not like terms, is what I'm trying to say. X to the third and x squared are not like terms. X to the fifth and x to the first are not like terms. Now, y to the second, right? And 4y to the second are like terms because they got the same variable with the same exponent. All right. So when you're dealing with variables, in order for them to be considered like terms, they have to be alike. They got to be alike, right? So meaning they got to be the same variable and they got to have the same exponents. All right. Even if you got a group of variables in one term, let's say you got x to the third, y squared, z. If you got x, then you got another group of terms. You might have x to the third, y to the fourth, and z. Those aren't alike because even though the x term, the x and the z match up, the y's don't. The y's have different exponents. All right. So again, the rule is all numbers are alike and all variables, right? All variables that have the same exponents are alike. So let's look for some like terms. Now we like playing a game now. I think this part is always fun to me, right? It's called find the like terms. So I see a 20x to the third, but I don't see no other x to the third terms. So that means 20x to the third is by itself. It doesn't have a like term. Then I see 4x squared. And I also see negative 40x squared. So these are like terms. These match up. 4x squared, negative 40x squared. Same variables, same exponents. Same variables, same exponents. Same variables, same exponents. Those are like terms. So it's like you playing a matching game. Even if you're like an elementary school teacher and you have your children, your students, matching numbers up, matching up colors, matching up toys, matching up fruit, matching up different, sporting equipment, objects, whatever it might be. This is the same exact thing that we're doing right now. Then I see a 24x and I see a negative 8x. Those are like terms. Because that's x to the first and that's x to the first. The coefficients can be different. Keep that in mind. The coefficients can be different because the coefficient just tells us how many of that variable we have. This means I got 24 x's. This means I got negative 8 x's, right? But it's still x to the first. That's still x to the first. All right? It's kind of like $1 bills and $1 bills. You put the $1 bills with the $1 bills. You got 24 of them. And then over here, this is a debt. You owe somebody 8 of them. Let's say the x squareds were $5 bills. You got 4 of them. And you got a debt of negative 40. Well, you owe somebody 40 of them, right? But they still $5 bills and $5 bills. $1 bills and $1 bills. You can think of it that way. Now this negative 48, there's no other number or constant by itself. so it doesn't match up with anything. So we just leave it. So this is how we write the answer. We write the answer as, let me get my black marker. Write the answer as 20x to the third. We put that first because usually, technically it's not wrong if you don't do this, but usually your lead term is going to have the biggest exponent. And then the terms will be written with descending order of the exponents. So if you got 20x to the third first, that's the biggest exponent. And then your x squared term is going to come next. But you know what? I neglected to combine like terms. I matched them up, but I didn't actually combine them. My fault. We got to actually do 4 minus 40. 4 minus 40. 4 minus 40 is negative 36. That's negative 36. So that's minus 36x squared. 20x cubed minus 36x squared, right? Then we got the x terms. So we got 24x minus 8x. 24 minus 8 equals 16. So that's 16x. So that's plus 16x. Plus 16x. And then last but not least, this minus 48. This minus 48 is by itself. So we got minus 48. So these are all four terms. 20x to the third minus 36x squared plus 16x minus 48. And this is the typical standard way for multiplying a binomial, which we call this a binomial because it has two terms, just like a bicycle has two wheels, multiplied by a trinomial, right? Just like we call a tricycle because it has three wheels. This is a trinomial because it has three terms, 1, 2, 3. All right, and this is the final answer. 20x cubed minus 36x squared plus 16x minus 48. All right. Now, let me show it to you a different way, though. Let me show it to you a different way, too, because this is one of the other ways that we could use. Because let's say this gets a little, like, confusing for you, because it can get confusing. You could create a grid that kind of looks like a multiplication table. You can do that. So I'm going to create a rectangular grid that has two rows. And two rows because this expression has two terms. So each of these terms is going to have its own row. And then it's going to have three columns because this is a trinomial, which has three terms. So each term has its own column. So, boom. So that's my rectangle. And then I cut it into two rows. Two rows because 4x and negative 8. Two terms, two rows. Then I'm going to cut the columns into three. I'm going to make three columns. 1, 2, 3. 1, 2, 3. Three columns for each of these terms. All right. And then I'm going to write them outside. So I'm going to write 4x adjacent to the first row. I'm going to put 4x right here. I'm going to write negative 8 adjacent to the second row. I'm going to write 5x squared above the first column. I'm going to write x above the second column. And I'm going to write 6 above the third column. All right. And then I just multiply, right? Similar to or exactly like how a multiplication table is set up. I'm going to multiply 5x squared by 4x. 5x squared by 4x. 5 times 4 is 20. X squared times x is x to the third. So in this box, I write 20x to the third. 20x to the third. And then 5x squared times negative 8, I write 5 times negative 8, which is negative 40. And then I just write the x squared because that's part of the product. X squared is part of the product, right? Even though there was no x term that the 8 had, it doesn't need to, right? So then I write 4x times x, which is 4x squared. Then I write negative 8 times x, which is negative 8x. Then I write 4x times 6, which is 24x. Then I write negative 8 times 6, which is negative 48. All right. Now it's time for me to combine like terms. These are both x terms. Combine those. These are both x squared terms. Combine those. And then you write your final answer. So our final answer is going to be just like before, 20x cubed. And then we combine the x squared terms. So we got minus 36x squared. And then we combine the x terms, which is going to be positive 16x. And then this minus 48 is just kind of there, just hanging out by itself. All right, and this is our final answer. And this is the same answer we got when we did it the other way, when we just did, we multiplied this 4x by each of these three and got our 3 terms. Then we multiplied negative 8 by each of these 3. And we got 3 more terms for a total of 6 terms altogether. All right, so that's that. This is a good skill to have, multiplying polynomial expressions. These are called polynomials. This is a binomial. This is a trinomial. Those are 2 types of polynomials. All right. So if you want to do more practice with these, just do a Google search, go online and type in multiplying polynomial expressions. Polynomial, multiplying polynomial expressions. Look for a worksheet. 1,000 links will come up. I promise you. All right. And just get some practice. I showed you how to do it in a couple different ways. Now it's time to do some practice to get ready for this test. All right. And until next time, I'll catch you in the next video. Peace.